Welcome to EconTalk, part of the Library of Economics and Liberty. I'm your host, Russ Roberts of George Mason University and Stanford University's Hoover Institution. Our website is econtalk.org, where you can subscribe, find other episodes, comment on this podcast, and find links and other information related to today's conversation. Our email address is mail@econtalk.org. We'd love to hear from you. Today is July 27th, 2010, and my guest is Robert Laughlin, the Ann T. and Robert M. Bass Professor of Physics and the 1998 co-recipient of the Nobel Prize in Physics. Bob, welcome to EconTalk.
My pleasure.
Now, you recently wrote an article in the American Scholar called What the Earth Knows, which is an interesting title, but the cover of the issue had a more provocative title, The Earth Doesn't Care If You Drive a Hybrid. That could be very dispiriting to some people, and it could be very encouraging to others. What was your argument?
The argument was that the scales of the Earth are so long that all it cares about is whether you burn up all the coal and oil. It doesn't care whether you take 200 years to do it or 300 years to do it. So if you're concerned about the Earth instead of yourself, you would have to bring your carbon consumption down to zero on the scale of people. Now, whether that's likely to happen is another conversation. But anyway, that's the answer to your question.
So, should we worry about climate change based on your argument? What was the thrust on that dimension?
Obviously, you should worry about climate change. Some. It's one of the many things you have to worry about, of course, like keeping your job and making sure that your kids are okay and making sure you've got enough money in bank for education and so forth. Sure. The rather provocative title and the subtitles of that piece were imposed by the editor of The Scholar, who saw an opportunity and took it. The original title of that piece was Geologic Time. And it's a chapter excerpt from a book I've written called, provisionally, When Coal Is Gone. The premise of this book is that you go in your mind to a time about 200 years from now or so when nobody burns carbon out of the ground anymore, either because they banned it or because it's all gone.
Or it's inaccessible economically?
Yeah, it's the same thing.
Is that what you mean by all gone?
Same thing,
okay.
All gone. It just costs too much gas.
Okay.
So it's exhausted, it's functionally exhausted. Then you ask, what happened? So, for example, you could ask, are there still soccer moms? Mm-hmm. Do people still drive cars? Do people still drive airplanes? Do the lights turn on? Is there enough food to eat? So those are very concrete, what I like to call engineering questions. Very concrete, specific engineering questions that you can ask. Interestingly, when I lay the whole premise out in front of students, they usually come down on the conservative side, even people who are very, very concerned about climate. So I ask, will people drive cars? And they say, sure. Then I ask, why?
Or how?
Well, you get to the how later, okay? The how, of course, is the next question, but they beat around the bush a little bit, and they say, well, because you need them. It's because you need to transport food. And then about the fifth or sixth person who raises their hands gets it. They say, because people want them. Then I say, yes, yes, it's because people want them. If you go to anywhere in the third world and go in a taxi and have a conversation with a taxi driver, it's always the same conversation. Okay? What he cares about is cheap gas. And he doesn't get paid enough, and he needs more money for the kids, and wants a better house, and so forth. It's always the same. Any country you pick.
Do you have to go to the third world for that? I think you can get that here.
Well, the point is, most people in the States are very parochial and inward-looking, and they don't understand that all those other people are just like them.
Yeah, it's strange.
Okay. Yeah. Anyway, so they get it, and then we start down the road. Well, if you're going to have cars, well, how are you going to power them? Well, then we talk about the technical means, and then we ask, well, what's likely to be the pricing of these technical means, and what are the fundamental limits on the various kinds of fuels you might have, and so forth. And the ones that are technical trains get it right away. They get it very fast. That hydrocarbons which we burn today, have the greatest energy density possible of all fuels.
We're talking about coal and
well, talking about coal, but
petroleum.
That's right. Things that have carbon in them, and so, for example, if we get to the next question, which is airplanes, will people fly airplanes? That's a little harder, but usually people say in the end yes for the same reasons, and then I get them. I say, well, how are you going to make the airplanes fly?
Yeah.
Okay, well,
pedaling really quickly.
Batteries are pretty heavy. Well, then the ones that have technical, it go click, 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 it goes in there. Oh, you can't have airplanes unless you have hydrocarbon fuels. I say hydrocarbon. You could in theory do it with hydrogen or something, but hydrogen is highly dangerous and it's an obnoxious fuel. The carbon in those fuels remediates the design flaws of the hydrogen, so it's a mix of them. So, but quantum mechanically, which is the way in the sense of chemistry, we know that the energy content of those fuels is optimal. There will never be anything that beats them. And there's the additional factor that for all the bad rap that carbon has, it's the only industrial pollutant that isn't poisonous.
Right.
Okay? In fact, plants need it to grow. I mean, they just remediate it. So in fact, you can very easily figure, working backwards from the problem, that we will never go into a post-carbon era. That is to say, even when the coal and oil are gone, human beings will still use carbon-based fuels, even if they have to make them. And that's a very excellent starting point for working backwards now for the climate issue, because one of the shibboleths is now knocked out, which is that carbon is bad. That's gone.
Why?
Carbon, well, because carbon with us forever. Of course,
let's stop there. I want to come back to the future in a minute.
Okay.
I want you to lay out the arguments you make in the American Scholar article about the role that geologic time plays in helping you think about this, and why you're more sanguine about the consequences, I think, than most worried people are. So give us the argument for why, say, 1,000 years of excessive carbon in the atmosphere or global warming is nothing to be deeply worried about. Because that's, I think, the way you frame it in the article.
Well, it isn't exactly.
Okay, so frame it better.
That's the rather conservative spin that the editor put on the titles. The first piece of the answer to your question is that the Earth is extraordinarily old. The measure that I used to bring it into perspective was rainfall. So I point out the amount of rain that typically falls, let's say in New York City, is about a meter. The amount of rain that's fallen since the Industrial Revolution began is about 200 meters, the size of Hoover Dam. The amount of rain that's fallen since the time of Moses is enough to fill up all the oceans. The amount of rain that's fallen since the ice ages ended is enough to fill up the oceans 4 times. The amount that has fallen since the dinosaurs died is, if I remember my number correctly,
I think it was 100.
No, it's 12,000. It's enough to fill up the oceans 12,000 times, or the Earth once.
Oh yeah, here. 20,000.
20,000. Well, it's even worse than I said. Okay, 20,000. No, I checked those numbers, so that's great. Now, the point is that you can get a feed. You know because you experience rain how long it takes to accumulate an entire meter of rain. That's about the size of a dog. Okay, so we're talking about filling up all of the oceans 20,000 times. That's a long time.
Not just since the dinosaurs.
And that's just in the dinosaurs. When we go back to the Paleozoic and so forth, it's even more. And as far as we know, based on radio dating, the Earth is a good fraction of the age of the universe old. Now, what that means is that the time scale of people, which is of course important to me, is irrelevant to the Earth itself. That means if you're going to think scientifically about the problem, you must separate the issues of the Earth from the issues of people, because they're different time scales. I care a lot about whether we don't have food in one generation. That's sort of on my plate.
You might care a lot about being able to see the other side of the Grand Canyon for the next 50 or 60 or hundreds of years.
Beautiful example.
For your children, grandchildren.
Yeah, but this is an issue for me, not an issue of the Earth. All of the events of carbon will play out in about 2 centuries from now. And that is a flash of geologic time.
A millisecond.
Much less than that. Okay, so the Earth will go on, and in fact, once you've got that far in your reasoning, you understand that the human life, human species, and the way we live and so forth is part of the Earth. So civilization isn't going to stop in 200 years either. It's going to go on and on and on. Well, in some form. Now, it might not be such a nice transition to this long-term situation, but you can predict with immense confidence that there will be people around after the crises are all through. And for a lot longer than the duration of the crisis itself, where human civilization is already, let's say, 5,000 years old, and the future spreading out before us is vastly longer than that.
But we care more than just about the Earth rotating or going around the sun, right? So we care about the quality of life on Earth. So you make some interesting observations about, I think one of the things people worry a lot about is, true, we might be here, true, the Earth will still be here. It is impervious to humanity, certainly, and it's from space, some dimension from space.
Although it looks pretty neat seeing all those lights down there.
Yes, it is, and it's also very blue. People like that. A hotter world, some people worry, will have less life on it, perhaps, and that would be a very bleak Earth. So, while the Earth might persist, aren't we worried about what will happen on the Earth in our lifetimes and the next few generations?
The answer to that is certainly yes. It is climate. Now, at this point, let's make clear now, we've now digressed onto the subject of climate, which in my book is assiduously avoided.
Okay.
I basically want to defer to the IPCC. If you want advice about what to do with your economy or what laws to write, go to them. Okay.
That's the International Panel of
or whoever.
Change.
You go to climate people. I do not want to get into a conflict with those guys. What I want to do is be a problem solver. So we're going to skip over all that stuff.
But what if all the life's gone? We can't. We're going to.
Well, I've just explained now. The life won't all be gone. That's nonsense. Now, why is it nonsense? Well, when you have these very grand, futuristic questions, they're so hard to visualize that it's difficult to do at first, but actually it's not difficult. And the logic is actually very simple. The lever arm of what people are doing to the Earth now is much smaller than what has happened to the Earth in the past, for reasons we don't know. Now, we're talking, just to put this in perspective, we're talking about maybe raising the sea levels by a meter. Now, there is no evidence yet for any elevation of the sea levels, but let's say for the sake of discussion that the worst case scenarios are right. The seas go up by a meter. Well, 10,000 years ago, let's say 20 to be safe, the sea level was 130 meters lower than it is today. And the reason for that is that all that water was locked up in ice over Scandinavia and Canada. Moreover, this is not science fiction. There are beautiful measurements done with carbon-14 in the muds at the bottom of the ocean that tell you exactly how much water was locked up in the ice caps. I checked all those numbers. They're very, very beautiful experiments. So you really know how much water was. Well, that's an effect on the sea levels that is 100 times bigger than the one you're contemplating as your worst case scenario. So something happened back about 3 million years ago that started this that's Pleistocene ice cycles. Nobody knows what that is, but it was a gigantic climate effect. Now, if you go even farther back in the geologic record, you find evidence, it's a little fuzzier because it's farther back, but evidence of very warm periods. So current thinking, for example, is the middle of the Jurassic was a very warm period. The Earth was kind of jungly, and the pole there was life at the poles as well as at the equator. There are theories for why that was, but the thing to keep in mind about that sort of time, way back in the dinosaur time, is that the record is much deeper, and so that means the errors in interpreting it are maybe a little bigger.
Sure.
But the Pleistocene is just crystal clear, crystal clear. So why did that icing happen? Nobody knows. Okay, nobody knows. And was it a instability of the oceans, or did the sun get dim, or was there something?
Yeah.
Well, there are a long list of things that you can think of, and there are good reasons for disbelieving all of them. Okay, so not necessarily the right reasons. I mean, one of them might be right, but we just don't know. So, but what you do know is that something happened that people didn't cause, and the reason you know that is there weren't enough people on the Earth at the time to do anything, and at the beginning of the Pleistocene, there weren't any people on the Earth at all.
Yeah. So the bottom line is the Earth's had a lot of climate swings in its existence.
In its history. Right.
In its history. During that time, there was life of various kinds. It seems to be a fairly resilient system overall. And
it seems to be pretty resilient, yes. Of course, it's history. You know, the history belongs to the victors, right? So the animals and plants that won and didn't become extinct, of course, they crow and they say, "Well,
great system,
great system. Life goes on." The ones that didn't make it, well, maybe they didn't like it.
So if a meteor, 10 kilometers wide, hits the Earth a long time ago and darkens the skies for a long time, it could make life tough for the larger creatures. So some people suggest that's why the dinosaurs aren't here anymore.
Right.
And that was an unpleasant event for them.
I saw that movie, yes, and if it happened today, that would be a pretty unpleasant event. Right. So, so one thing you know for sure is that life, by its nature, the way life is built generally, is that it's adaptable. Now, people, you might ask, well, could people adapt to this warming? Well, of course, you don't know until it happens. But don't forget, humans are the most adaptable form of life that has ever existed on Earth. Okay, they live in the pole. They live in the poles. They live with the penguins. They live in the jungles. They live in the Great Plains. They live in Chicago, for God's sake.
Yeah, Philadelphia.
Well, okay. So the point is that people are
L.A.
LA is the worst.
We're sitting in the Bay Area, so I think LA
exactly.
is the right.
Well, I don't know. If I were going to say what's the toughest place, I'd say Chicago. But let's say people are very adaptable, and so the good money says that humans will do pretty well. Now, the other species around might have a little tougher time of it. You've got the temperature moving around. That's a little bit harder to predict. They've done it before. Okay, they've done it numerous times before. There's a famous case that geologists like to talk about, which is Oregon. In the Oligocene, which is a little after the dinosaurs died, western or eastern Oregon was wet. And the reason you know is you find all these redwood debris. And so it had redwood forests like the coasts do, but then the Cascade Ranges came up and made a rain shadow, and they are no more. So what did those plants do? Well, the ones that were growing in that particular area died, and the ones that were growing in other areas didn't die. They're better.
They migrated a little bit, the best they could.
Well, the way plants migrate is the ones in the bad place die, and the ones in the new place don't. So the other species, anyway, might have a tough time of it, and you're of course aware that zoologists, basically, people who worry about enumerating the life on the Earth are very, very worried about human impact on other species diversity loss. And that's a little hard to measure, but it's highly believable that human population pressure is doing a number on the species count of the Earth. So I don't, as I say, my own personal guess is that that's true, and that if we're going to worry about anything right now, that's it.
Biodiversity due to population pressure on habitat.
Well, there's
resources.
a lot of things you do. For example, people are worried about the Amazon jungle going on. Well, why? Because they're farming it. Okay, they're cutting down all the trees, just like the Europeans did when they came to America, and they chopped down all the trees in the river bottoms in the Middle West. So, so the trees are gone, and they're using insecticides, and they're building homesteads, and this is not so good for jaguars and parrots.
Yep.
Okay. That is an issue of geologic time. So you're worried about the arc of the Earth.
Sure.
The 4 degrees. Let's not be too precise. Let's say the amount of heating that we're talking about due to carbon profligacy, to me, is a much less severe difficulty than the speciation problem, because losing the species is forever.
Now, before we go on, which I want to get back to our beyond the coal carbon world, but a lot of folks are a lot more worried about the impact of that whatever number of degrees it is on the adaptability of species and the biodiversity issue. Why do you think that is? I think you're saying, well, they're very flexible. It's a relatively small amount of forecasted. We don't, of course, have very accurate forecasts, but it's a small amount of variation relative to the historic record. Most people don't feel that way. They're very concerned about it. What do you think their argument is? Do you know? Have they argued with you?
Sometimes. But the answer to your question, I think, is that it's a powerful metaphor.
Yes, it is.
For yourself. The integrity of the Earth is, at least in part, a religious principle, and it's certainly built into Western religions. I know about them. Eastern religions is a little more complicated, although it appears to be built into those too. And so worrying about the Earth, leaving your campsite the way you found it, okay, strikes chords in people that have nothing to do with logic or science or any of that stuff. It's
deeply in us.
That's right. It's deeply in us, and it's not wrong either. Certainly, when I go camping, that's what I do.
Yeah.
Right. You can't tell I was there, and that's the ethic. And when I die, I want my ashes to go right in the ocean where they'll do some good, so I don't clutter up the ground with a lot of mess. Anyway, so that's the reason, is because when people are talking about the Earth, they're not actually talking about the science of the Earth. They're talking about the metaphor of not harming things.
Yeah.
And that's it's very understandable. Now, the reality, as you know, is that humans harm things. Our mere presence harms things, and so real life is a balance between the harm you do on the one hand and the need to do a little bit of harm in order to live. So, in fact, this absolutist position is not completely correct. It's one end of a spectrum.
There are trade-offs. You're suggesting that the magnitude of the trade-off is relatively
right. Right. So the easiest way not to besmirch your campsite is to not go camping.
Yes.
Okay. But of course, I like to go camping, so I do. So the compromise I strike is I go and I use the resource a little bit, but then I put it back
as best you can.
Put it back. Right. Now, the boundary condition or the fact of fossil fuel use is that it's a historic accident. It comes to us from Europe. First of all, it's an accident that stuff is in the ground in the first place, but also it's an accident that our present-day prosperity is built upon it. So you cannot simply wave a magic wand and stop that use of the resources without causing mass death, either through starvation or just plain war over the remaining resources. This is serious, serious stuff. So the transition that's coming in the next century or two has to do with retooling something very fundamental. It's like you bought a car, and the car has worked for years for you, and then you discover it needs new pistons. Okay, well, that's an expensive job, and you really don't want to replace the pistons, because you're going to have it rebored, and it's going to cost an enormous amount of money, and then when you get done, the car's going to run just the same as it did before, so you put it off. Okay, but you can't put it off forever, because eventually it won't work anymore. So then you have to go and fix it.
It's kind of like Medicare. Right? Today,
well, maybe
working pretty well. It seems like if you're in the hospital, but
maybe the funding algorithm for medicine has some very profound problems with it that are fundamental, and yet eventually, you can go for a while, but eventually it won't work anymore. And you don't want to deal with it, but you'd like the next guy to deal with it. Okay. So it's like that, and since it's so fundamental, the retooling will be very unpleasant. There'll be a lot of economic instability that happens when it occurs, and one of the things you've got to worry about, I think, is managing that. So let's be very precise. So let's suppose, just for the sake of discussion, that you don't do anything, and then we wait for the oil crisis to come. Now, everybody's always predicting there's going to be an oil crisis, but actually this time you sort of know. And the reason you do is because the Energy Information Agency has revealed that the amount of new strikes of oil, big as it is, including the big Brazil ones, is not enough to offset the declines in U.S. production. If you remember your history, the U.S. used to be an oil exporting country, and it's blessed with huge oil reserves. Well, the new sources are not enough to counteract that. So the draw on the Middle Eastern reserves is going up.
Correct.
And so that means you can calculate when the crunch time is just with the Middle East resources alone. You just calculate how fast they're going down, and when it hits zero, then you're going to get a price instability.
Well, I find that a bit mysterious for the following reason. Maybe you'll correct me. And I have to mention, on my way into running an errand this morning, I heard on KFOG, local radio station, a caller reprimanding one of the disc jockeys for thinking that a wind turbine in your front yard would be ugly and might offend your neighbor. And they were very quick to say, no, it would be beautiful. It would be beautiful to have a wind turbine in your front yard because it would be sustainable. Of course, I'm not sure what a wind turbine in your front yard could sustain at current technology of wind turbines. But isn't it possible that as the amount of carbon diminishes, and of course, the amount of known reserves has risen for a long, long time. So in 1970, when scientists were forecasting the end of carbon by 2000, when 2000 came along, even though we had used a lot more carbon between 70 and 2000, we'd found so much more, whatever that means. It's, of course, a hard thing to measure. But isn't it but eventually, the Earth is a finite place. Isn't it possible that our effectiveness in using the amount of carbon will rise, as it has, right? We're more energy efficient than we were 50 years ago. The amount of GDP we can get per BTU has gone up dramatically. Isn't it possible that we'll find ways to power our electricity, our cars, and our planes so that a gallon of gasoline goes much, much farther than it did before, and reduce that pressure you're talking about on, say, the Middle East oil fields? Do we have any idea about what
you're asking me is a speculation about what will happen technically in the future and what supplies will do in the future. Well, the best answer I can give you is I looked at this question very, very carefully when I was writing this book. And it wasn't easy because the oil industry is vast, and those guys know much more than I do, and it's very hard to assess what's true and what's not.
Yeah.
My best guess as to the true situation is that the Middle East reserve problem is real. That is to say, the Middle East is not the major source of imported oil to the U.S. Our major source right now is Canada.
Yeah.
Also, the reserve numbers are way off, at least the BP ones that I know of, because they didn't include the oil sands of Venezuela, which are vast.
So they're off in the sense that they're understated. They understate the true reserves.
They way understated them.
Aren't there shale fields somewhere else too besides Venezuela?
There are other sources around, but the really big one that help you can really concrete say that there's a problem with the numbers is the Venezuelan resources.
It's a cheerful thought.
Well, yeah.
I love Venezuela.
That's a whole conversation in itself. What's happening in Venezuela right now is fascinating. The Middle East reserves are, in fact, being drawn down more, and so something will happen when it hits zero. It might not be the end of oil, but it's a good guess that there will be price fluctuations like crazy when that happens, and there will be something economically that occurs at that point, and that point is roughly 60 years out. Now, at current drawdown rates, so you might ask, well, maybe some improvement in technology would reduce the drawdown rate. All I can tell you is that it's gone up. Okay, it's gone up monotonically.
China's grown, India's grown,
well,
the U.S. has grown.
That's the big effect, obviously. The Chinese don't have any oil. The USA has lots of oil, China doesn't have much. From their perspective, it's a completely different calculus. They've got to worry about have adequate fuel supplies for an economy that's growing madly.
Yep. Right now.
And the same goes for the Indians. Actually, the Chinese are growing faster, but they both have gigantic populations. And if you know human nature, every one of those people is going to want a car.
They all want a car. You bet.
Absolutely. So So I think and then you asked about the technical constraints. My guess is no. You can get more bang for the buck for fuel, but the economics of fuel use precludes it, because fuel is so cheap that it doesn't pay to conserve it. And as long as that's the case, the technologies that might get another 20% out of the fuel aren't relevant.
But as the 60 years pass, or maybe it's 100, maybe it's 40, we don't know, but as those years pass and we get closer to zero, or economic zero, as the carbon-based fuel gets scarcer, its price will rise, and those technologies that are not economic today will become
exactly and
viable.
Apropos of that, I made a prediction.
So, by the way, I just want to say, I don't think it's necessarily that prices will fluctuate wildly. I think they'll grow steadily. It's a question of the speed.
The people I know on Wall Street, basically ex-students, all thinking that the first sign of the oil scarcity isn't price going up crazy, it's price fluctuating like crazy.
Yeah, why?
Well, because of the I presume that there's a buyer response. It's like the business cycle. Okay, well, people want to buy when it's cheap, and when the price goes up, they don't buy, and then there's a crash, and so forth. The oil supply is very inelastic. When what happened? We had a recession, and it tanked. Price of oil tanked, even though it's absolutely essential to life. The reason is there was a giant amount of supply and no demand. Anyway, I will defer you to economic experts for that. Now, the simple thing that you can say technically, which
I don't think
true.
there are any, but keep going.
Well, maybe there aren't any.
There's a lot of guessers.
They're placing their bets, and it's their money, and that's what.
Good. That's important.
If you've got money and it's your money, and you're placing the bets, that makes you an expert, as far as I'm concerned.
with you there.
Well, the technologies to replace oil, basically to make gasoline from other things, already exist. It's not that you need to do fundamental research to figure them out. They've existed for a long time. The main pieces of them were invented before World War II. The Nazi government actually made gasoline, not very much, but they made it.
Because they had lost access to their oil supply
Well,
at some point in
this
the war.
is all World War II history. Germany has had and always and still does have an oil problem. They don't have oil supplies. At any rate, you ask, why don't you make your gasoline right now and stop using foreign oil? Well, the answer is obvious. It's too expensive.
Yeah.
Okay. So, what you expect to happen is a price crossing.
Mm-hmm.
Okay?
Sure.
Now, right now, the prices don't cross. Why? Because the
cheap.
people it's more than that. It's basic economics. Now, this is a theory I'm telling you, but I'm pretty sure it's right. The energy business is cutthroat. That's the key thing to understand. The reason gasoline is cheap, relatively speaking, is because all those companies are basically trying to kill each other.
It's a beautiful thing.
It is a beautiful thing. So it's actually, right? So their nightmare is that synthetic fuel plants get built. Because once they do, the feedstocks to them are cheap. See, the entry barrier to making synthetic fuel is the plant. It's the capital cost. So you don't want your competitors building those plants. How do you defend against that? Low prices. Okay, this is classic J.D. Rockefeller thinking. Okay,
I'm not sure it's true, but that is the one view. I'm not sure it's a strategic plan on the part of these folks. Rather, just maybe this is the thing that they think the best thing to do. But either way,
let me come back to that, because there's a thing I discovered when I was writing this book that is just a gorgeous case of this problem. But at any rate, the plants in question, not only can you make them, they're already built. Now,
synthetic fuel.
Well, let's say that first of all, the Germans did it, but there have been improved versions. The South Africans built one, a famous synthetic fuel company called Sasol, that makes synthetic diesel fuel and still makes it. It's boutique diesel fuel, and it's expensive. But when I was in Northeast Asia, I learned that the numerous Korean companies had quietly been building pilot plants near Chinese coal mines. Why? Because they want to learn how to do it. So they're ready. They're just waiting for the prices to cross, and when they do, bang, they'll be there. Now, the environmental argument for not subsidizing building of the plants is that the carbon footprint's double. Carbon footprint is bigger.
Of a synthetic.
Correct. And the reason why, carbon footprint is bigger, so people, the Greens, don't like it.
Okay. Why is the footprint bigger?
Well, it's very simple. To make gasoline out of coal, you need hydrogen. And the way you get the hydrogen is from water, and getting hydrogen out of water costs energy. So basically you have to burn some of the coal to get the energy to make the hydrogen. And then you burn other parts of the coal to get the carbon that goes in. And so basically the carbon consumption has doubled. Mm-hmm. Yeah, okay.
Aren't we going to run out of coal, though?
Let me get to that.
Okay.
My own guess is a price crossing, and the reason is that I don't think governments anywhere have the willpower to do what it takes to get the prices to adjust artificially. Now, maybe they don't even have the means. Maybe it's physically impossible for them to do. That could be also. But certainly we've had numerous cases, both in this country and Europe, where governments have tried to modify the carbon, the fuel prices by taxes, and when they get a little bit too high, the truckers go on strike.
Yep.
Okay, and that's the end of that. Happened in England. It was very funny. The British government said, "We are not giving in to these people. We are not giving in to labor," and then they gave in.
Of course, yeah.
All right. Now, you asked about
running out of coal.
Running out of coal.
And why?
Well,
is that going to happen later? So that'll let us. And how are we going to power these synthetic fuel plants without coal-based electricity?
The way I think it will come out is that there will be first a crossing to coal followed 150 years later or so by a crossing into other carbon sources from plants. Why? Well, because assuming that the governments don't have power to stop price competition, they can't stop the price crossing either.
Right.
So the demand for fuel will be voracious, and the energy companies who are providing it will be obligated to get the carbon of the fuel, right, from the cheapest source. Anybody who doesn't use the cheapest source will get wiped out of the saddle quickly. Yep. It's like going extinct. Okay?
Yep. Happens all the time.
Right, and so I think that's probably what's going to happen. Now, obviously, if you could pass the right laws, you might forestall. You might just skip that step and go right to the long-term one. But my guess is that no government is strong enough to do that.
They usually don't pass the right laws anyway, I've noticed in my experience.
Oh, there's a whole...
They could get close.
There's a long list of reasons why you think that might happen. But the... Anyway, I'm trying to answer your question.
Yeah.
So the first price crossing is coal simply because it's cheapest. And then what about the second one? Well, when the coal runs out, you got to have carbon fuels because airplanes won't fly without them. And why do you need carbon? Well, as I said, because it's so good. So you have to get it. Well, where is it? It's all in the air. So you have to get it from the air. Well, you can do that with a factory, or you can do it with plants. My money says it will happen with plants because they're so great. Right? Basically, they've been honing their skills for 600 million years, and they really know how to do it. They're good at it. So they're just tailor-made to take carbon out of the air for you, and all you do is add water and sunlight. Okay? So I don't think it's likely to turn to artificial carbon sources. I think probably a new branch of agriculture will spring up at that time to basically provide the feedstock that coal used to provide. And the beauty of the history is the capital costs will already have been made. Capital expenditures will already be. In other words, the plant that makes fuel out of coal is the same as the plant that makes it out of...
meaning the factory.
Yes,
yeah.
The factory is the same as the factory that makes it out of grass clippings. It's exactly the same. Everything's the same. So once the plants have been built, once the factories have been built, it's actually fairly easy to switch them over from the fossil carbon source to the non-fossil one.
But that would enslave the plants, of course. I don't know. It may alarm some people who want the plants to be free, but it's an interesting scenario.
Well, it's actually more than a scenario. It's going to happen with 100% certainty, and the reason why is that you can't make airplanes fly without carbon, and that's where all the carbon will be. So you have to get it. You have to get it out. Now, let's go back to the question you asked now about sort of bigger, which was, well, what about all the coal in the ground running out? Couldn't you just pass laws to stop that? Well, here's where the geologic time matters. You see, if you make cap and trade, and you cut down on your carbon use, your coal use by 20%, that merely extends by 20% the time it takes to use it up. So that doesn't make any sense. You have to reduce it to zero.
Now, the only argument really that I think has any water, which doesn't float for me, is it's immoral to use the coal. So we should leave it where God or nature put it, which is under the ground. So when people tell me we shouldn't use plastic bags, I always say, well, the plastic bag's made out of oil. The oil went under the ground. We'll put it back under the ground in the form of a plastic bag. It's really not so horrible, and I'm usually being facetious there, having a good time.
The immorality of using the coal is just fascinating because you really get some tests about how moral people actually are when you push them to the wall on this. Now, I have a chapter in this book about the California energy crisis.
This book is not out, by the way.
That's not out yet.
But it will.
We're in contract, and and I've got the advances and
but we're talking about a forthcoming book, which will at some point be able to order at Amazon.
Right. See, I lost my train of thought.
Morality.
Oh, yes.
Push people to the wall.
The California energy crisis, of course, is contemporary, but it was so extensively reported that you can see very clearly what happens when people don't get their energy. Okay? They go crazy.
Yeah, they don't like it.
They chop off the head of the governor, even though the governor was not responsible for the problem. Okay? They basically become irrational. This is apropos of asking the students, well, in this time in the future, will the lights go off? Okay, and they sort of think it won't, but then we talk about this history, and they say, boy, it really won't. Namely, it's politically impossible for the lights to go off.
People really don't like reading
People
in the dark,
really don't like
sitting
it.
in the dark.
And when we were in that crisis, no one talked about saving the earth or the ecology or the blue sky or anything. They just said we're having brownouts. Get my lights back on. Exactly.
Or my air conditioning if you're living in the hotter parts of the state.
That's right. Yeah. So the moral argument is fictitious. Actually it's a metaphorical argument. In real morality, like you have in Greek tragedy, there's a choice. And you have to make the choice. And you make a moral choice when you do the tough thing. Well, my experience with most people is they will never do the tough thing when it comes to energy. They're so unbelievably weak, and this is especially true with left-leaning people who haven't thought through the numbers very carefully. Now, I hate to be accusatory that way, but it tends to be true. I say this shocking thing. You know, when you cut down on the coal use, you're burning more natural gas. Okay, because that's where the energy comes from. Are you sure you want to do that? It puts carbon in the air too. Well, it turns out that doesn't compute. See, because the idea that energy is conserved and that you must have it from somewhere doesn't.
We'd like to not think about that.
Well, it's not that you wouldn't like to think about it; it's that you don't. Okay? In other words, for most people, it's kind of a tax that you're going to put on someone else, and you'll just order them not to burn coal anymore. And then they will, and everything will be fine. Well, of course, everything won't be fine. What they'll do is they'll burn more natural gas. In fact, I find myself amusing sometimes that maybe the Russians are secretly behind it because they have so much natural gas. When I was in Germany last month, that conversation was, of course, very shrill, because Germany is a big coal-burning country, and they've made definitive statements, no nukes, we don't want nuclear power. I talked to the Minister of Science and Education, and she was telling me about how they put caps on coal, and I said, well, doesn't that mean you're going to have to pay the Russians more for natural gas? And she says, that's a problem, and then change the subject. Okay? Well, the Russians are pretty good business people. They're probably grinning ear to ear. Go Greens, go. I feel obligated now to go back a minute and tell you a story.
Go for it.
Apropos of conspiracy theories. There was one that documented in this book that actually came out in the Wall Street Journal. That's where I found it. And it was the summer of 2007. And this was simply wonderful. It had to do with biofuels. At that time, there was in the Congress a law that's now been signed into law called the Energy Independence Act of 2007. And there was a provision in it that the government, which is to say the Air Force, should procure some large fraction of its fuel from non-traditional sources by, I think, 2030.
Plenty of time.
Well, I have to be careful about what I say is fact, because this is all from memory. But anyway, sometime it was a lot. It was a big fraction, like 20%. And then the Wall Street Journal reporters noticed that a coalition of Greens and big oil put a rider on that clause, which was that the alternate fuel so procured must not put more carbon into the air than petroleum distillates would have. And they thought that was enormously amusing, and I got it instantly. Because you see, when you do that, you knock out the coal companies. Okay? Now, I'm pretty sure that there's only one thing in this world that a big oil company is afraid of, and that's a big coal company.
Yeah.
Because the coal companies can do it. Okay? You want to stop using foreign oil, they can do it. You build the plants, bang, they got it. Well, so you want to stop those guys. What better way to do it is to get in with your pals, the Greens, and require that you not put more carbon in the ground. Then no government subsidies to build the plants, then no competition for you.
Yeah. Longtime listeners will recognize the Bootlegger and Baptist Coalition here, which we will link to our earlier podcast, the coalition of the high-minded, high morality Greens with the self-interested, not so high-minded oil companies.
Well,
it's not the first time, by the way.
Not the first time, and people who are very well-meaning basically get taken advantage of by people who are a little more savvy than they are.
That's so true. Let's shift gears, because we'll talk about some of your other work, and particularly two of your books that are in print. The first is The Crime of Reason, where you argue that that there's an increasing, you call it a sequestering of knowledge, that there are areas of the intellectual enterprise that have been put off limits either through legislation or taboo because they are perceived to be dangerous. And you include in there nuclear weapons, biological understanding, where people are worrying about the weaponization of say, smallpox or other plague, anthrax, etc., cloning, and even intellectual property. How real do you think this problem is, and why did you write that book? What are you worried about? On the ground, what are you worried about? You're a professor here at Stanford. You get to teach, quote, whatever you want, not literally, because there are probably you'd get in trouble if you taught your students how to make a suitcase nuke, I guess. So yes, that is off. That's that.
And
knowledge.
Not from the university either.
What?
Not just from the university either.
Yeah, you're right. It wouldn't just be you'd get a letter from the provost. So it's true that if I'm an inquisitive mind and I'm one of your students, you can't. And I don't know if you know how to make a suitcase nuke, but if you did and I wanted to know it, you probably wouldn't tell me. So there are some areas that are off limits. Why is it so worrisome? What are you worried about? Because it's a worrisome book.
The broad brush answer to this question is that I've lived through a deindustrialization experience, which is the offshoring of electronics, microchips, to the Far East. In fact, I spent 2 years in the Far East doing administration in a university, partly in response to this problem. The logic is, well, if that's where the industry went, that's where you go. Okay. Now, through thinking about that and things related, what happened to machine tools, what's happening to cars, what's happened to chemical processing, what's happening to oil industry and so forth. They basically manufacturing going overseas. I realized that something had happened in the 70s which was very profound and which has long-term implications for our country. It's very insidious, actually. Back in those days, we collectively made a decision that it was okay to make the process of making things abroad because you were going to be an information society. In fact, the term information age got coined at that time. The idea was, well, you don't need to make things anymore. You live off information, knowledge, basically. So you're going to be the smart people, and you're going to know things, and then you're going to tell the less endowed people overseas how to make stuff, and then they'll make stuff for you at cut rate. Yeah, you give them the capital, and then you get the stuff, and then you don't actually have to do anything. You just manipulate other people. Now, we roll the camera forward and we have the Digital Millennium Copyright Act, which is making it illegal to understand things. Now, understand, the word we use is decrypt, but from a computer programmer's point of view, there's no difference between decryption and understanding. They're the same thing. Computer programming to them is language. It's not a secret technology. It's language. It's not a thing. It's concept. And of course, that law and the strong increase in the power of the patent laws has been very stressing for a lot of people who are working in private industry, at least the people who are working at the lower levels, because they see that their aspirations to get this technical knowledge and to become rich with it are blocked by the fact that this knowledge is owned by somebody, and they can't do that. Now, you'll see on the internet a lot of talk that's kind of radical about how these people in the Congress don't know what they're doing, and they're in the pocket of big business and so forth.
In allowing more aggressive patenting of intellectual ideas rather than just gadgets. One
of the things I pointed out, I understand this a little better than most people do, and what I pointed out in this book is that that's not the situation at all. The situation is, in fact, that the people in the Congress are desperate. They're desperate to keep those things, those ways of making your living that still exist in the country, and they're basically pulling every lever they know how to, including making goofy laws, because it's the 11th hour. One by one, you're losing things that people use to make a living.
So you're suggesting that the increased scope of patent laws is a response to the flow of jobs and knowledge overseas?
Yes.
Okay. I don't agree with you, but go ahead. Let's hear the rest of the argument. Why are you worried about that?
Because that was my take on it.
Okay.
When I saw what had happened and where the job flow went and so forth, that was my understanding of what the law meant.
Okay.
Both from what I saw and also I read it. And the same goes for the patent laws. They're basically, the knowledge for the sake of itself is not very useful to us. We want things that are owned by us, that if someone else learns them and takes them, then we can prosecute them in our courts because that's against the law. Now, what's the problem? Well, the problem, what I figured out after thinking this through, is that it's actually quite fundamental and obvious. It's sort of elementary economics. If you live in a world where knowledge is the currency, there must be less of it. Why? Well, because no one will pay for something you can get for free. So in the Jeffersonian ideal world, everybody's a farmer, and they write letters to each other. They exchange information, but they charge you for corn.
Yeah.
Okay? And the world we grew into, or have grown into increasingly, is where we have to have secrets. We're a society of secrets because that's how you make your living. Making your living is not nice. Okay, we're not going to share with you. I'm only going to give you the thing if you pay for it. And my measure of success is whether I can shoehorn a very large amount of money out of you for this thing. And, of course, the way economics works is that process isn't solid unless you really don't want to give me the money. Okay,
right.
So it's pain. So the amount of pain that you have to pay is a measure of how valuable the thing is that I'm giving you. So, in the information world, where information is your economy, there has to always be pain in exchange of information. There has to be money exchanged.
There has to be something scarce
it has to be
to
scarce,
make great value.
Okay, and that means that strewing the world with enlightenment can't be. Also, so knowledge can't be free anymore. Not only that, but the sense of the law is that it's not just acquiring knowledge, it's if you go and acquire it yourself, you are violating the law. Namely, in some cases that is this criminal act. So it's not just learning things. It's stealing. It's okay. Yes. So learning things of technical value is theft, and that means that the whole idea of just learning stuff and bettering yourself from what you learn doesn't make any sense if the thing in question is valuable, which is to say, if it's owned by someone else.
And yet, that's a very interesting perspective. So let me give you a counterpoint writ large. I'm not going to we don't have time to go into the details. I too worry a little bit about the profusion, expansion, and scope of patent law and intellectual property. I think we've made a mistake, or at least we've gone too far, but I'm open-minded about it. I might be wrong. I don't know. But what I notice is that in this world we live in, where knowledge is hoarded, as you point out, is secretive, and because only, as you say, only scarce knowledge has economic value. It's the only way I can charge for it. And yet I look around, and again, here we are at Stanford, where people are attending and acquiring, paying a great deal of money, bargain at twice the price, of course, but they're paying a great deal of money, some on other people's nickel, but a lot of people here are paying a lot of money to acquire knowledge that they presume is useful. The pace of innovation is pretty healthy. There's places where I wish it were healthier. Obviously, we don't know what the alternative world would look like, but it's not like we live in a world where we're sort of stuck. So, how would you answer those points?
The first one, I have a politically incorrect answer.
Okay.
But I'll tell you anyway. The business model of
a man who writes that doesn't care if you drive a hybrid,
well,
even when it's not his title, is certainly immune to worries about.
Well, I did put that in there because it's true. You know, everybody drives a Prius. It just takes 10% longer to use up all the oil.
Go ahead.
The business model of elite universities is not education; it's access to the peer group.
Yeah, there's a lot of truth to that.
The actual education you get is pretty generic, and if you were really diligent, you could open books and read it.
Yeah, this is
what
true.
You're actually selling is access to other students and to the
colleagues.
That's right. So it's basically a gateway to certain things, and that's what you can charge for. You can't charge for knowledge. Now, the pace of innovation.
Does that hurt you? So we found a way.
You know, that's the way it is. I would prefer a world in which the state would pay giant amounts of money to pay professors to strew knowledge and enlightenment around to the people who need it. But that's not the world we live in.
Yeah.
Okay. So I make my way as I can, and I'm talking as contrarian as I possibly can. But in fact, there's a simple idea here, which is that people who try to repeal the laws of economics fail.
Yes, they do.
Okay. The pace of innovation has increased. As far as I can tell, there is no objective evidence at all that the pace of innovation has increased, at least technically. In fact, quite the opposite. The pace of innovation has actually decreased. And let me give you some very concrete examples. You probably have a little thumb drive, a little flash drive. This is the technology that destroyed the film industry. This technology is Japanese. It was based on something invented at Intel called an EEPROM, which I worked on as a student. The problem was that EEPROMs couldn't be erased electrically. You needed a little ultraviolet light to do it. And a very famous engineer working for Toshiba, who's now in Sendai, invented a way to do it. And one thing led to another, and the film industry is gone.
You're talking about camera film.
Yep.
And others.
Camera film's gone. Okay.
And it's a great world. I love the world, digital world.
Another example is the blue diode. That's a famous one. When I went to school, we all learned that you couldn't make blue diodes because the energy gap of the silicon wasn't big enough. And anyway, if you tried to make other semiconductors, that they would have chemistry problems. And well, nobody told this guy. Okay, so he just did it.
Yeah.
Okay. And then now we have blue LEDs all over the place.
Why is that important, by the way? What's good about a blue diode?
It's a technical detail. It allows you to replace incandescent lights with diodes, which you couldn't do before because they were too red.
Okay.
There are other reasons, but that's the big one.
Okay.
Of course, the really famous example is the flat panel display, which was an utterly brilliant Japanese invention. It wasn't based on anything new. What they invented was a process. It basically has a huge number of processing steps, and what you have to do is get the flow of your product through this processing so that you get a very tiny loss per step, so that by the time you finish all these steps, you have a reasonable yield of your product. So the invention was the process. Another thing, everybody said that you could do that, and they just did. So now the cathode ray tube, which is our television that we used to remember, they're gone. No one remembers what they look like anymore. They've just vanished off the face of the earth. There are innovations in automobiles that you know about. You go down a list, where are the most innovative automobiles? You ask a kid on the street, he'll tell you they're in Japan or Germany, they're not in the USA. When I was raising my kids, I did this experiment. I was trying to teach them things. My older son, he was a little boy, and I said, okay, here's the Earth. Show me where cars come from. And he turned the globe around and pointed to Nagoya. Okay. Now, there's a lot of software that happens. I mean, a beautiful example of American innovation would be the iPhone.
Yeah, for sure.
Okay. So we're not dead. Okay. But what is true is that in the hardcore stuff, the capital of innovation is Japan, not America. And that's just the way it is. Now, whether that will continue is anybody's guess. There are things going on in the Far East that are fascinating. Japan's ex-colonies, which means South Korea and Taiwan, are now doing to it what it did to us. The flat panel displays that you buy are not made in Japan, even though the invention comes from there. They're made mostly in those countries and now increasingly from mainland China. Almost all the flash memory doesn't come from Korea anymore. It comes from China. The cheap pots and pans that you used to find that are made in Korea are now made in China. Same goes with the bicycles that I just bought. I just bought a new bicycle down here that's made in China. Okay. So the textiles, last time I was in North Carolina, there was discussion about the exodus of the textile industry and the making sort of innovations in textiles, but where are those innovations happening?
I assume China.
Not in Raleigh.
Yeah, right.
Okay, I've made my point that the innovations idea is partly untrue, and how much it's untrue, I have difficulty gauging.
But why do I care if they're made in Japan or South Korea or Taiwan or instead of Raleigh? I get to use them. I mean, I'm glad. It's nice that Steve Jobs is an American, I suppose. If I like the iPhone, it came from an American, but if it had come from a Japanese and I get to use it, why would I care?
All I can tell you is that that this is playing out now, and I guess we'll see.
Yeah,
an experiment is 10 times better than any theory. So you see. So maybe it's true that that you can do without all that manufacturing capability. I don't know. I guess we'll find out. However, this is not what we're talking about. What we're talking about is innovation and how great American innovation is. And what I think is that American innovation is in fact not nearly as great as the proponents say it is, basically because they're not telling the truth.
Okay. Could be. Do you have 5 more minutes?
Sure.
I want to talk about your other book before we leave. Okay. And then maybe another time we could talk about it more length, because I just found out about it this morning. I hadn't known about it. We have another book called, so the book we've been talking about is The Crime of Reason. We'll put a link up to it. But the book I want to close on is A Different Universe, Reinventing Physics from the Bottom Down. And you suggest in that book, based on my summary reading of the summary, that we ought to be taking a different path in our thinking about the universe and the physical world. And we ought to be looking more at emergence, which is a favorite topic of this program, in the economic sphere. rather than reductionism. What do you mean by that? And where do you think we ought to be going?
Well, I mean the same thing you do. There are things that happen in systems that you don't manage because you don't understand them. That this should happen in economics or human creations like government is obvious. Everyone knows this. But what is not so obvious is that it happens at the most primitive levels of nature as well. The call for a new way of thinking, of course, is slightly hype. I don't want to tell people how to think. I do have a real problem with ideologies, especially in science, because it's supposed to be expunged of them, and of course it isn't.
Nope.
Tons of ideologies, and one of those ideologies turns out to be that you can understand all things by taking them apart. It's surprising for me as a physicist to be talking about this, but I discovered it slowly over the course of time, working with very practical things like transistors and magnets and chemical reaction and so forth. The belief is easier for people to swallow than the facts. Of course, this is well known to us from politics, but
our
turns
earlier
out
theme, yeah,
absolutely it happens in science too. And so part of the impetus for writing this book is I just had it. Because I can see, we were talking about before, there are these industrial things that are happening that really matter. They really matter, and we're waving our hands about the theories of the universe and all things, and this is an ideology problem that's run amok that is very detrimental to your well-being.
Such a great insight, though, the way you phrased it, because it's so human, and you see it in any child, an inquisitive child, wants to take things apart to get down to the basics, right? And that's what we've been doing in physics for how long now?
Well, you've been doing it for a long time, but in fact, in real physics, you do both. Real physics, the first law of theoretical physics is never argue with the data. Now, it turns out that physics is really about law. It's not about reductionism, it's about law. It's about quantitative relationships among measurements that are always true. And law in physics seems a self-evident thing, at least if you're a Westerner, because it's a religious principle. There should be law, right? The lightning comes down from the sky, and that's the way it is. In fact, much of our view of physical law, Newtonian law, is just that way. It actually has its roots in religious thinking. But there are other kinds of laws, things that are always true, that don't just come from the sky, they're made. And my favorite example is rigidity. So here's this pen, you see it's rigid. And that's a law. Now, to prove to you that it's a law, let's imagine that you're up at 40,000 feet in an airplane eating peanuts. You know that the plane won't fly apart. Why? It's a law. Something you can stake your life on, and in fact you do every time you fly in an airplane or ride in a car or a bus or anything else. Now, where does that law come from?
You're talking about the rigidity of matter.
Rigidity. Where does that law come from?
Because evidently it's made of little smaller things.
Well, that's what
that's what they say.
And then you say, well, I know why it's rigid. It's because it's made of little atoms. Well, of course, that's obviously absurd, but it's even worse than that. It's experimentally wrong, because if you take a small bunch of atoms and do nanoscience on them to see what their properties are, you find they're not rigid.
Yeah.
There's something called quantum mechanics that makes them kind of squishy. Okay? So in fact, rigidity is a law of nature that is like the beauty of a pointillist painting. So it's like a painting of Monet. If you get up close to it, it's meaningless little dots. Okay, but as you go back and back, and sometimes it gets bigger and bigger and bigger, it makes more and more sense and becomes more and more clear until it becomes perfect. So one of the origins of perfection in the physical world is organizational. There are other examples, of course. In physics, we like primitive things, so we know the primitive examples. That's the simplest one, but the one I spent a lot of time invested a lot of time is superconductivity. The ability of electric currents to flow perfectly. Same story. When you chop it down to a few atoms to see how the superconductor works, you discover it doesn't work. Or something we call superfluidity in helium. Same story. If you just get 5 or 6 helium atoms to see where this behavior came from, this amazing behavior, you find it's not there. It's an emergent law.
The whole has properties that are not visible.
They're encrypted. That's right. It comes from the parts, but it didn't have to have been. You could have used other parts, and the behavior would have been the same. This idea or behavior phenomenon occurs a lot in physics. In fact, there's a fancy mathematical name for it, which we call universality. And physicists, most of them, feel more comfortable mathematicizing the behavior than to think of it as a physical phenomenon. So you'll find people say, well, the reason this universal behavior occurs is because field theory says it so, because my mathematics says it should. Whereas in fact the reality is the mathematics works because it happened. Okay? All the errors in the equation vanished away because the behavior in question is universal. It doesn't depend on details, and so you can take the wrong equations and solve them and get the right answer. Well, that happens a lot, not just in tabletop science, but in the universe itself. So the so-called standard model of elementary particles, which is our understanding of the vacuum, has things in it that we talk about in reductionist terms, but are in fact emergent, like this famous Higgs boson, which is now under investigation at CERN. That is like a sound wave. Okay, it's a sort of collective motion of whatever this stuff is that's in the vacuum. In fact, the entire idea of the space as empty Newtonian nothingness is actually refuted by the body of experiment that we have, which shows that it's filled up with all this stuff. And the stuff is elastic, that's what gravity is. And you can bonk things out of it, which is what making elementary particles is. And why it's as simple as it is at the scale of people, no one knows. You just have to postulate it. So you know for sure it's organizational, but and it's quantum mechanical organization like you have in a solid. But what's happening microscopically, you can't tell. As you go to take it apart, things get more complicated. They don't get simpler. And that's always what happens when you have something that's organized itself. When you try to find out its secrets, you find out way more than you want them to know. And it gets more complicated. You don't need to know all that stuff. So anyway, it's very common, and the most primitive, so the whole being bigger than the sum of the parts is in fact common in nature. And one of the arguments that I made in this book, and it's the key thought-provoking thing, is that this is the origin of all law, not just some of it. In other words, our concept of the law just is, as a practical matter, is not compatible with experiment.
Meaning?
Meaning that all the physical laws that we know of are emergent. Every single one of them, even the ones we worship as being the most microscopic of all, it turns out there's something underneath them.
So that the experiments work only because we're approximating?
No, it's because when you do the experiment slow and at long length scales, the properties become universal, like rigidity, and then that's a law. And then the little pieces out of which it's made don't matter anymore for anything that you measure. They become invisible as far as your measurement goes, and so you can just postulate them away. It's a practical matter for the particular thing you're looking at, right? So the idea that law is something that's always true could be emergent, that's a little shocking. People, because, as I said, because of our cultural traditions. So this particular book is actually about that. It's the origin of law in the natural world. And that's, a lot of people said, well, this is a totally radical view of the world, and of course it's not. It's simply a worldview that all of us use every day when we're dealing with real experiments. Everybody knows it's so. It's just we have well, it's not the language we use.
It's interesting. You talk about the cultural. Why do you say we have a cultural discomfort with that?
Because I have lived and worked in parts of the world where the culture is different. And I've become very cognizant of the fact that your Judeo-Christian roots powerfully influence everything that happens in this country, in Europe, in Canada. It's people like to think of themselves as beyond all that stuff.
Sure.
But it ain't so.
It's spread in our bones.
It's certainly, I don't know about your bones because your bones are physical, but certainly in the culture you live in, what seems obvious to you, what seems right to you, and so forth, has cultural roots that are very deep and are religious.
But we'll close on this because we're getting long, but that story you just told about the whole being greater than the sum of the parts, the universality of law, the inability to observe at a micro level the macro reality, you could flavor that with Judeo-Christian understanding, right? There's a certain divinity to that, if you wanted to put it that way. There's a certain fundamental mystery there.
Sure, you could. Just a little parenthetical remark here. Our religious traditions are complicated. We think of them as Hebraic, okay, but they're not completely. There's a big chunk of them that's Greek.
Yeah, sure.
And in particular, Greek Stoicism. And so the Greek traditions have atomism in them, and they have emergentism in them also. And what happened in the early Christian days is that those ideas got amalgamated with Jewish religion. And as a result, you're right, we have little bits of that in our culture. If you open up the Bible, you will find at the beginning there isn't any emergent anything. Okay?
It's top down.
That's absolutely it's top down, and the law is what it is, and it has just this scary, fearsome thing that you normally think about. If you don't obey the law, it will be extremely bad for you, so you better.
Yeah.
Okay? And so that is different from let's have a committee meeting and make the law.
Yeah.
Different. And so both of those traditions are there even in Christian culture. Both of those traditions are there, but the deeper one is the more tough. You don't obey the law, and the lightning will come.
Yeah, but ironically, the oral law in Judaism is a committee. It came out of the Sanhedrin, which was a group of wise men who made the law real on earth, took control of it. So it's interesting.
This is another conversation which we have another time. But you can imagine that when I was living in Asia for a long time, I thought very deeply about this because it's an inherently non-Christian place, and it's a Confucian place, and there are just different ways of looking at things. And one of the key things I realized was the idea of the one correct thing is missing. So to a Western person, it makes perfect sense that there should be one correct thing, not two.
Yeah.
And if there's two, you get upset. Find out one of them, at least one of them must be wrong.
Yeah.
Right? Well, in Confucian cultures, that worldview is called monism. And it's pejorative.
Uh-huh.
It means that you're a child if you think that way. You're just making trouble. You want to have fights all the time. The key to peace is to have more than one truth. You have your truth, I have my truth. Your reality, my reality, and we just won't fight. So there isn't one true thing. There are many. Now, this is not to say that one or the other is better. I'm just saying that for me as a Western person, I'm definitely a moralist in my science. One thing I won't tolerate is wrongness. And so my Western roots are very, very deep. So naturally, I see that as the worldview that's the best of all possible worldviews. But it isn't the only one. And the thing that you realize is that the logos, which is what that idea is an invention when it comes to the application of it into the laws. It's not a self-evident way of living. It's in fact a way that was invented that makes certain things happen that are good.
My guest today has been Robert Laughlin. Bob, thanks for being part of EconTalk.
My pleasure.
This is EconTalk, part of the Library of Economics and Liberty. For more EconTalk, go to econtalk.org, where you can also comment on today's podcast and find links and readings related to today's conversation. The sound engineer for EconTalk is Rich Goyette. I'm your host, Russ Roberts. Thanks for listening. Talk to you on Monday.